Hey guys, HackerSploit here, back again with another video, and in this video I'm going to be talking about Docker for penetration testing and bug bounty hunting. Now, why am I making this video? Well, the first reason is, of course, I get tons of requests, regarding how one should go about setting their pen testing or bug bounty environment. And of course, various options come to mind, or various solutions come to mind. One of them is, running a VM with an offensive distribution like Kali Linux, Parrot OS. You get an idea. You get the idea. There's a plethora of pen testing distributions. The other option is to go for frameworks that install the tools for you. A good example of that is the Pentester framework. You also have the ability to use, Kali repos if you're running Debian or a Debian-based distribution. But I think one of the technologies that has gone under the nose of many in regards to pen testing and bug bounty hunting is Docker. All right. So the reason I'm actually covering this is because I actually want to show you why I believe Docker is a fantastic technology and how it can aid us in pen testing and bug bounty hunting in regards to setting up your environments, getting the tools that you want ready and available when you need them, and of course for education and learning and practicing, for example, with vulnerable web apps, etc., right? So without any further ado, let's get started. So if you're wondering what Docker is, or this is your first time hearing about Docker, Docker essentially allows you to build and deploy applications and services in the form of containers. Now, this may seem familiar to you if you've heard of Linux containers, like LXC, etc. That's a bit different, and I'll explain why Docker does it much better, right? So you can look at Docker as a platform as a service offering that utilizes the host operating system kernel as opposed to traditional VMs where you have to install the guest operating system on top of the host operating system for each virtual machine. This will make sense in a second. So the containers contain the dependencies and the libraries that an application or a service needs to run, therefore eliminating the need for installing the dependencies manually. So what this means is that if you're a developer of a tool or an environment or operating system or a web application, you can essentially use Docker to create Docker images that can be then turned into Docker containers. And what you're doing essentially is you're setting up this service web application in the form of an image that can then be run as a container on literally any operating system that supports Docker, which means the end user doesn't have to worry about installing the dependencies required to run the application or to set up the application. All right. So with that said, Docker containers are much more efficient than virtual machines as they utilize the host operating system. And after the developer or the author of the Docker image has set up their Docker image and the environment, the end user doesn't have to do any of that. All they need to do is download and install Docker and download the image, and they're essentially done. Right, so let's take a look at how Docker differs in terms of its infrastructure and how it works to a traditional virtual machine or a hypervisor setup. So on your left, you have your Docker infrastructure, and on the right, you have your virtual machine infrastructure. So right over here, you have your infrastructure layer, where this is your hardware layer. So you could either be running a laptop, desktop, server. It really doesn't matter. You then have the host operating system, which in most cases is going to be Linux, with the exception of Windows. But even when you have Windows, you're essentially virtualizing Linux and then virtualizing Docker on top of that. So I'll get to that in a second. So you have the host operating system, you then have the Docker daemon, and then you have your containers, right? So you might be saying, well, that looks quite similar to a virtual machine. However, you're missing a key part here. You don't have to install guest operating systems for any of these containers because they essentially use the host operating system kernel. So let's take a simple example here. So let's say I download an Ubuntu image, right? An Ubuntu Docker image. So you might be saying, well, isn't that an operating system? Well, it's essentially, it contains all the tools that makes Ubuntu what it is, right? So let me give you an example. So let's say I'm running Manjaro as my host operating system here, and it could be running a kernel version 4.15, and I download an Ubuntu container. What's essentially happening here is that Ubuntu container is going to use the host operating system or the kernel of my host operating system. So it's going to run on the same kernel, which means you essentially do not need to install the actual Linux kernel for that particular container. It's on the only thing that's running on it are the tools that make Ubuntu. So it could be, the services that are running, the various tools that are installed. You get the idea. I could also be running an Apache web server, and again, it's running on the host operating system. Remember, it's not running on its own operating system. So that means utilization is drawn down or is lower when using Docker containers or Docker images. Now, when you talk about a typical hypervisor or virtual machine, you can see that you have your infrastructure. You typically would have your host operating system, which if you're running it on a desktop, but on a server, you have your hypervisor. And then your hypervisor could be anything, from VMware or Proxmox, regardless. And you then have to install, for every virtual machine, you have to install the guest operating system. So if you wanted Ubuntu, that means I'll have to install Ubuntu, the kernel included, right? So you can definitely see the advantages. Now, that being said, Docker is typically or is primarily a DevOps tool. And the problem it solves is this. So let me just give you an example here. So let's say you're setting up an application, you're the developer of a web application that uses the LAMP stack. Let's use a simple example here. So it's quite a complex web application that requires specific libraries and dependencies installed for each layer of the stack. So for, you have Linux, of course, that's number one, Apache, MySQL, PHP. And for each of these setups, you require specific dependencies and libraries. Now, you can imagine after setting up the web application and having, this very granular hosting environment set up, you now need to work on the deployment of this application. And this is where the problems start to arise, because when the developer passes his application on to the ops team, whose primary purpose is to deploy the application, they will have problems because they need to install the correct operating system. They need to start installing the dependencies, and it just takes a lot of time. Now with a Docker image, right? So what this developer can do is create a Docker image that sets up the environment the way it's supposed to be set up, and then creates this Docker image or builds this Docker image from a Docker file. And then with this Docker image, it can then be passed on to the ops team, and this Docker image can be run with one command on any environment, so as long as it has Docker installed, right? Because the Docker image it will essentially set up the environment itself without any intermediary there. So the developer just does it one time, and they're able to deploy the applications on on various operating systems that support Docker. So let's take a look at some of the advantages of using Docker for pen testing and bug bounty hunting. So number one, it provides you a multi-platform solution or base for running containers. So that means that you can design a toolkit, or you can design a system or a collection of tools or vulnerable web application, and you can run it on Windows, Linux, and Mac OS simply by installing Docker on all of these hosts, and you don't have to do anything else. Right. Secondly, we already have containerized offensive distributions like Kali and Parrot. Many people ignore them, and I'll explain why. And they are part of the problem as to why there hasn't been any adoption of Docker in pen testing. You then have containerized vulnerable web applications like OWASP, JuShop, damn vulnerable web application, more of which we'll talk about in a second. You also have the availability of pen testing and bug bounty toolkits, and I actually have created one, and I'm going to be sharing that in this video. And lastly, it's much more efficient than running a virtual machine, and you'll see exactly why. In regards to the size of files you'll need to download. Secondly, in regards to how quickly you can launch a container. And lastly, in regards to the overall performance and reliability of using Docker. So in the next part of the video, we'll get started with setting up Docker and how we can, and we'll be taking a look at all of these tools so that you can see the advantages of using Docker for pen testing and bug bounty hunting. So I'll see you there. All right, so now that we've taken a look at the importance of Docker, the advantages it offers over running a typical hypervisor VM environment, Let's take a look at how to get it set up. Let's take a look at the various commands that Docker or running Docker entails, and we'll take a look at the various pen testing images and tools that we can utilize with Docker. All right, so the first thing we want to do is we want to take a look at the installation process. Now, to do this, you want to head over to docs.docker.com. Now, I'm currently running Ubuntu. If you go, this is the Docker documentation repository, and you can check the, you'll find the installation instructions for Windows, Mac, and Linux here. So if you're running this on Windows, if you're running Docker on Windows, go ahead and do that. If you're running it on Linux, you get the idea. And also for Mac. Now, you can install Docker from your various package managers. If you are using an Arch-based distribution or Arch Linux itself, you can use the AUR. I'm pretty sure Docker is already available on the AUR, so you can easily install it from there. If you're running Ubuntu or Debian, you can install Docker directly using the Aptitude package manager. However, you can also use the convenience script right over here. When you click on installation for Linux, you can see the supported editions are Ubuntu 19.04, 18.10, 18.04, 16.04, etc. Right? So what you need to do is the easiest way to install this is to install it with the convenience script right over here. So the convenience script will essentially automate the installation process. So you can see, just download the script, run it, and it should install Docker for you. As I said, you can also use the Aptitude package manager. So what I can do is I can say sudo, for example, sudo apt get install Docker, and I hit enter. Let me just enter my root password here. And there you are. So I already have Docker installed, and you can enumerate the Docker version by typing in Docker version. Simple enough. And hit enter, and you can see that it gives me the version that is installed right over here. So make sure you have the latest version, and we can finally get started. So I'm just going to walk you through some essential commands that you should understand. So first of all, Docker should be treated as a daemon or a service, which means that you need to enable it or start it whenever you want to use it. So if you find yourself using Docker more and more or often, I really recommend that you enable it to start to actually run on startup, and you can do this using systemd system control. So to do this, again, sudo system control, and we say enable Docker, and we hit enter. So I already have Docker enabled on start. So that essentially means that the service is enabled. Now when I want to run it or when I want to start the service, I simply say sudo system control start, and I say Docker, right? And I just hit enter, and that's going to start the Docker service. I can check the Docker service here, and you can see it tells me it's loaded and it's running. All right, so now when you have it running, let's talk about images and containers. So an image is essentially what you'd expect. It's simply an ISO, for example. Let's just use that basic concept. So it's not yet been turned into a working or a running container. So the images are what you download to actually use without them being set up yet. So if I type in Docker images, you can see that it's going to tell me permission denied, and that's what I wanted to get at. So you do need root privileges here. So I'm just going to say sudo bash here, because I do want to demonstrate this without any hitches. So I'm going to say Docker images to list all the Docker images, and you can see that I have various images. Let me just run that one more time, and let me expand this. So you can see I have a bug bounty toolkit that I created. I'll get to that in a second. I have another image here that I was working on, I was developing. I have Ubuntu. I also have the Kali Linux Docker image right over here. So one thing that you will see is you have the repository name, the size, the tag, the image ID. This is very important, as well as the repository name, because that's how you will essentially manage them. So for example, if I wanted to download a Docker image, I would go to the Docker Hub, right? So I'll just go into my browser and I'll go to the Docker Hub, and this is where you can find various images. So for example, it tells you right away you can search for great content like MySQL or any other service, and you have tons of services that have been added to to the Docker Hub. So if I search for Ubuntu, for example, you can see that it's going to tell me this is the official Ubuntu Docker image, and it'll essentially give you a repository, and the Docker pull command is what will download the Ubuntu image for you, right? So I can copy this, and once I run this, it will essentially download the Ubuntu image for me. So I can just paste this in here and I hit enter. It's going to tell you it's going to use the default tag, which means it's going to download the latest version of the Ubuntu Docker. If you want to specify the version you want to download, you'd use the colon and specify it right over here. So if I wanted Ubuntu 18.04, it's gonna connect to the Docker Hub, and it's gonna look for Ubuntu, and it's gonna use the tag that I've specified here. And in this case, the tag is the version. And in most cases, for the official images or for the officially supported images like Ubuntu, you can see that you have the ability to specify the tags, and the tags are essentially representatives of the version. So you can see I specified 18.04. You can also specify 19.04, 19.10, 16.04. You get the idea, right? So you can see that I already have it downloaded, and if I just display the Docker images now, it tells me that it actually gives me the tag as 18.04 now, which makes sense, and when it was last created on the Docker Hub, and its size, which is very, very important here. All right, so now that you know how to interact with images, let me show you how to remove images. So if I wanted to remove an image, I would say docker rmi or remove image, and then I would specify is its name or its image ID. So I can say Ubuntu, and you can see if I use the tab auto-completion, it actually auto-completes for me the name. Now it's very important that you use the image ID when you have a multitude of images that you're working with. So I can just hit enter and it's going to remove it. So now that I've removed it, let's actually take a look at some of the pen testing options so that I can demonstrate how to interact with Docker a bit more. So if I go back into the Docker Hub and I look for Kali Linux and I just hit enter, you can see we have Kali Linux by Kali Linux. That's very important. And you can see that this is a deprecated former official image. And essentially it gives you instructions as to what it is. Now let me explain a few things here. I appreciate the fact that Ubuntu has actually gone out of the way and created a Docker image for, Kali Linux. That's perfectly fine, but you pretty much have to install or set up the container and then install the tools that you want. Now, this, in my mind, is extremely counterintuitive because when you take a look at the size of the image without even installing it, it's about 2.2 gigabytes. At this point, one would essentially just prefer, downloading the ISO and installing it on virtual machine. So I think this is one of the issues I've been having, and it's one of the issues I'm looking to remedy, and I'll show you how in a second. So again, you can essentially just copy the Docker pull command, which downloads an image. I already have it downloaded as I displayed here, right over here. So Kali Linux Docker. Now, if I want to run this image as a container, I want a container that is running Kali Linux. What I would do is I would say docker run, and I specify the Docker ID or the image ID or the repository name. So I can say Kali Linux, and I can use the tab auto completion. And once I hit enter, you can see we don't get anything. So this might be a bit confusing. Now, if you want to view the current Docker processes running or the current containers that are running, we type in docker ps, and that gives us the running Docker instances. Now, you can see we don't have anything running, which might be confusing you, but that means we need to list all that have been executed before Docker containers that have been run and are in an exited state. So if I hit enter, you can see we have Kali Linux, the command that was used when it was created, and the status. So you can see it's currently in an exited status. We also have the ports and the names, and I'll get to what these mean in a second, right? So what you're seeing here is essentially the Kali Linux Docker. We ran it. However, we did not specify any options or parameters to do or in regards to what we wanted to do with the Docker image. So to understand this, we need to go back into the official Kali Linux Docker webpage or the Docker Hub here. So if we just go back and click on the repository name here, you can see they also have the bleeding edge Docker, the Docker image, and their documentation is horrendous, to be honest, and I'll actually show you how to run it. So if you want to run a Docker image that is essentially going to use your host Linux kernel, and is essentially just going to set up the tools that Kali is known for, or tools that are unique to Kali. However, in this case, there aren't any tools. You have to install the tools yourself, which is absolutely horrendous. So what I would do is I would say docker run. By the way, if you want to get rid of containers that you've already run, because this container is now active, which means I can actually boot into it. So I can say, for example, docker container start, and I would specify the container ID. And once it's started, it'll obviously go back into an exited state because I haven't specified anything. So what I'm going to do is I'm just going to say docker remove, and make sure before you remove any container that you've stopped it. And to stop it, we say docker stop, and we specify the ID or the actual name. So you just specify Kali Linux right over here, or I can just copy the ID there. So docker stop, and you can also paste the entire container ID, or you can enter the first three characters. So you can say 86C and hit enter, and it's going to tell me it's going to stop. Now I can also say start, and there we are. So we can say docker PSA. You can see that it was created and it exited 3 seconds ago. So we get the idea now. So what I'm going to do is I'm just going to say docker remove. Let me just use the previous command, or we can just list them one more time so I can remove it. So I can say docker remove 86C. So I'll use the first three characters and hit enter. If I run docker ps again, you can see we don't get anything. So if we want to launch or go into Kali Linux, we would say docker run. I can give it a name. I'm going to say Kali, and we want an interactive terminal. We then specify the repository name or the image name. And after this, we specify what we want to run, or the command we want to execute, which in this case, we're going to bring up the bash. We want to run bash on this particular container. So that will give us an interactive terminal with bash running. And once we hit enter, you can see we are now logged in as root into the container with the container ID specified right over here. So if I say cat etc issue, and I hit enter, you can see we're running Kali rolling here, and I use release, and I hit enter. You can see we're currently running Kali version 2019.3. all right, so let me open up a new terminal here, and I'll just go back into bash, and let me just show you something with the kernel. So if I display the kernel on my host operating system, you can see it's version 5.0.0. If I go back into Docker and I say uname R, you can see it's also going to be using the same as your host operating system. So one of the issues I've been having or trying to grasp here is why they would release a Docker image, and the excuse is that you install the tools you want, but it's so counterintuitive that you download or pull an image and then you want to use Nmap, for example, and it isn't even installed out of the box. The only thing they're packaging are the repositories, which is so absurd. I mean, it's unbelievable. So pardon me trolling or, ranting about this, but it's just horrendous. And the same thing goes for Parrot OS, right? These are just base images with repositories and tell you, okay, install the tools you want. Now, that's not what I wanted here. So I'll just exit, and again, if I just list all the containers, you can see it's now in an exited state. I can also use the previous, so I can say docker. If I say docker container start, and I specify the ID A2D, and I hit enter, and we list the current containers that are running, you can see that the status is now running, which means we can actually attach it. So to attach onto to a particular container, all we need to say is docker attach, and we specify the ID, also A2D, and we hit enter, and it's going to take us back into Kali Linux. So that's what I wanted to explain here. So if I just show you the Docker images now, you can see that we have the standard ones, and I've also set up my own one, which now is pretty much what I would expect a Docker image to be when talking about pen testing. But let me just talk about some of the environments you can set up. So sorry, I just opened up OBS there. So let me just go back to the Docker Hub, and let's say I was searching for Parrot, right? We also have Parrot here, and you must listen to what this is like. So official Parrot security image with basic security tools. All right, so they're doing a good job, and you know that's fine. But this is why people don't use Docker, man. And I'll show you how useful Docker can be, because I've set up my own image, and I'll show you how useful it can be. So let me just close the documentation page here. Now, the great, or the only people who are utilizing Docker well are the people creating vulnerable operating systems, vulnerable web applications like the OWASP Juice Shop. So if I say Juice Shop here, right, and I just hit enter, so there we are. Do we have the official one? I don't think so. Let's try OWASP. We also have Zap to Docker, which is great, and hopefully I'll cover it. It's essentially OWASP Zap, and you can use the Docker. You can use it to essentially launch a Docker container that runs OWASP Zap in your Docker, and you have to actually you have to map ports. I'll probably make a video covering that. I can't actually find Juice Shop here. Let me just go into the repository, but you can see they have various projects that have set up here, and they're the only group or company that actually are using Docker to its full potential. Now, let's see if I can find Juice Shop, because it should be here, or it was published under, let me just find it. So Juice, no, there we are. So it's by Kiminich, sorry, apologies for that. And so you can see we have the OWASP Juice Shop image right over here. And what we can do is we can just pull it. So I'll pull it right now and show you how fantastic this is. So I will pull it, and we'll just wait for it to download. I'm not really sure what the size is, but it shouldn't be large at all. And it's one of the best documented images that are found regarding pen testing, right? So we'll just wait for this to essentially just pull the image. So you want to give it a few seconds, because it has to actually has to pull the image from the Docker Hub. Once you have the image installed, you can instantly prompt a container or set up a container in a few seconds. So it's going to start pulling the latest image. So you want to give this a few seconds depending on the size of the image. So I'll just get back to you when this is done. All right, so once you've pulled the image, as we've done with OWASP Juice Shop, let me just clear the screen here. And if we list the Docker images now, you can see that we have Juice Shop downloaded, and it's about 280 megabytes. Now, let me just show you why this is like one of the greatest technologies in regards to deployment. So if you take a look at the Docker Hub, you can see that we have excellent documentation regarding how to run it. So Docker run, and the RM flag is used to specify that after the container has been run and you've exited, it'll actually clean up that container, which means you need to run a new session every time, or you can exclude that flag if you want to. You can also run it in a detached state, which I'll show you in a second. So the P option is to map ports internally and to the host. So the first option is the port you want to map on your host operating system, and the second option is the port you want to map in the container, right? So you can see that the service runs on port 3000, and we're mapping it to 3000 on the host. So that means we'll be able to access it locally, through localhost on the port 3000 once we run it, right? So again, running it is extremely simple, as we just need to follow the instructions. So we say docker run rm, and we can run it in a detached state, but I'll explain what that means. So RM, and we then specify the P options. We are mapping port 3000 on the host to port 3000 in the container, and we then specify the name, which is going to be, you can just use the auto completion here, and we hit enter. All right, so it's going to tell you Juice Shop is starting. It's a node application. All the dependencies are set. The server is listening on port 3000 and it's currently running. Now this is where you'd use the detach flag, which is denoted by a D. That means that it'll essentially go into the background while this is running, which is something that is very useful when running services like this, right? So I'm just gonna type in 127.0.0.1 and 3000. And that will load up OWASP Juice Shop for us immediately. So this is the power or the functionality that we're dealing with, right? And immediately all I can do is just hit Control C, and that is going to terminate it. And if I try and if I try and reload this, what am I doing here? If I try and reload this, you can see that the server and the container is terminated. And of course, because we specify the RM command. So if I say docker psa, you can see we only have the Kali Linux container that we had here. By the way, we can the containers save data or anything you actually were doing in them. So for example, if I just start the container, so docker container start A to D again, and I say docker, I can say docker attach A to D, and I hit enter, and I say sudo or just say apt. I believe I have to update the repositories even. So I have to have that additional step before I get what I want. At this point, I would probably have already set up a virtual machine and be on my merry way. But you can see that these are the environments we're dealing with. It just seems like a lazy effort. And you'll see why. You'll see why. Right? So I'll just wait for this to actually update the repositories, and I have to install nmap manually. I can't believe I have to do that. I mean, honestly. So apt-get install nmap, and I hit enter, and there you go. So oops, sorry about that, but anyway, you get the idea. So I will now I'll now remove this this container, and we can take a look at the image that I have created, right? So it's actually available on my GitHub repository. It's called the Bug Bounty Toolkit. So I get tons of requests on a daily basis talking about what tools I use for bug bounty hunting and why don't I make more bug bounty hunting videos. Well, here you go. You guys have forced me to do this. So this is a toolkit and a Docker file, a script, or whatever you want to call it, that you can use to set up the bug bounty tools that I use. So you can see there's a bit of an introduction, a multi-platform bug bounty toolkit that can be installed on Debian or Ubuntu or set up with Docker. So the installation script currently only works with Debian or Ubuntu, and it will install the tools that I've listed right over here. So it comes installed with an nmap, massscan, DNS enum, DNS recon, mass DNS, you get the idea, NocPy sublister, the S3 bucketeers, recon ng, SQL map, Nikto, WAFWolf, you get the idea. It also comes with sec lists, which is pretty much why my image is so large in the first place. So if I list the Docker images here, you can see that it's about 3.04 gigabytes. If I exclude, and by the way, the latest version of this image on my Docker Hub page, by the way, the links to all of this will be in the description, is about 1.2 gigabytes or 2 gigabytes. I'm not too sure. You guys can pull it and try it out for yourself. There's adequate documentation in regards to how you can set it up. So I'm currently working on adding other tools here. As you can see, we have Aquatone, GoBuster, Bucket Finder, all actually in development or being added right now. So you also have the Docker file in the event that you want to customize the Docker file and build your own image from this. So I already have it downloaded on my system. And let me show you what the advantage of having a well-built image is, right? So I'll just do this right now. So I'll say Docker run. And I'll give it a name, and I'll just call it Bug Bounty Toolkit, so BBT. And this is going to be an interactive terminal. I want that. And I'll say HackerSploit, Bug Bounty Toolkit, and again, bin, bash, and there we are. And I hit enter, and we are in here. And it's currently based on Ubuntu, but every tool works. And I'll demonstrate this to you right now. So Let me just bring that to the side here and I'll demonstrate that all the tools work. So let's try out Nmap out of the box. Remember, Nmap, there we are, it's working. Mass scan. And there we already have the I've linked the binaries, so you don't even have to navigate into a directory to use them. So mass scan DNS enum, there we are, DNS recon, there we are, all installed out of the box. Alt DNS. By the way, some of these tools cannot even be installed from various package managers. They have to be installed manually, which I've already done for you. So you just need to download this image and set it up as I just did, and you have all the tools set up. By the way, you can also run this on Windows, so remember the power you have here. I also have NocPy, NocPy set up here. So there we are, NocPy sublister. Sublist is set up. We have Deb. I'm working on installing GoBuster. We also have the Bucketeers. There we are, the Bucketeers script recon ng. That was one of these really important tools that I wanted to get working out of the box. There you are, perfectly working, the latest version. We also have, let's see, some interesting tools. SQL map works. There we are, SQL map working perfectly. WAF installed here. Comics also installed. XSS Strike here installed. We also have Hydra. So we have tons of tools in this toolkit. And by the way, the tools can all be found within your home directory. In the case of this script, they are found under the toolkit directory. If you do plan on using the installer script, this will only work on Ubuntu and Debian. I'm working on getting them working or getting an Arch installer script. But I recommend that you run it with Docker. If you do choose to download the seclists word list, you can find them within the word list directory. And I'm currently using seclists Lite, I believe, but you can see they all exist here, and we're working on adding more tools. I'm open to suggestions or feedback regarding how to improve this this particular image, but my goal is to have an all-in-one image for bug bounty hunting, and I'll be working on a separate one for pen testing, just to prove how much better it is than actually setting up a VM. Well, you only need a few tools for your web assessments or pen tests. So that's pretty much all I wanted to cover in this video. The links to all of these images will be in the description section. Let me know what you think. If you have any questions, I'd love to hear your feedback, and I'll be seeing you in the next video. Peace.